Now, we will be studying about the new course that has been mentioned over here as 60-minute YouTube course on Java. For understanding details about this course, we will have to move towards our next particular slide. In this slide, this is mentioned as course objective. So the objective of the course is understand Java's core concepts and why it is widely used. Learn how to install Java and set up a development environment. Write and execute their first Java program. Understand basic syntax, data types and control structures. Learn about object-oriented programming OOP principles. Get an introduction to file handling and exception handling. So now we will be moving towards the next particular slide for understanding what we will learn but in a course structured way. So the first module is Introduction to Java, where we learn the history, purpose and feature of Java. Understand why Java is platform independent, object oriented and widely used in enterprise applications, mobile development and beyond. Second, setting up the Java development environment JDE. Install a JDK Java development kit, set up environment variables and configure an IDE like IntelliJ, IDEA, Eclipse to start writing, compiling and running Java programs. Third, Java basics, syntax, variables and data types. Understand the structure of a Java program, define variables and explore data types. Learn how to take input, display output and follow proper syntax conversions. Control flow, conditions and loops. Master decision making using if, else and switch. And control repetition using loops like for, while and do while to implement logic in programs. Fifth, method and functions. Learn how to declare and call methods, pass parameters, return values, and understand method overloading. This module helps break large program into reusable, manageable blocks. Sixth, object-oriented programming concept. Dive into OOP fundamentals, classes, objects, inheritance, polymorphism, encapsulation, and abstraction. Learn how Java supports modular, scalable and reusable code with these principles. Seventh, exception handling and file handling. Handle runtime errors using try, catch, finally and custom exceptions. Learn to read from and write to files using IO classes like file reader, buffered reader and file writer. Java collections framework. Explore powerful data structures like ArrayList, HashMap, HashSheet, and more. Learn how to store, retrieve, and manipulate data efficiently using the Collections API. Final project and next step. Allow all concept in a mini project like student management system or file organizer. Review what you have learned. Explore intermediate topics and get guidance on advancing to Java frameworks or competitive programming. Now, who this course is for? This course is ideal for beginners who want to learn Java programming from scratch, including students, aspiring software developers, and coding enthusiasts. It's also suitable for anyone transitioning into software development or preparing for technical interviews. No prior programming experience is required, just curiosity and a willingness to learn core Java concepts and object-oriented programming in a structured, hands-on way. So now we will be moving forward to our first module, which is Introduction to Java. In this particular slide, we will be discussing about Introduction to Java. First of all, we need to go through the slide carefully. What is Java? A high-level, object-oriented and platform-independent language. Why learn Java? Used in web applications, mobile apps, big data and enterprise solutions. Features of Java. Platform independence, JVM, strong memory management and security, multi-threading and rich API, popular Java applications, Android apps, banking systems, web applications, etc. So this demonstrates that Java is a powerful and versatile programming language widely recognized for its reliability, security and cross-platform capabilities. Java is a high-level object-oriented and platform-independent language developed by Sun Microsystems in 1995, now owned by Oracle. Its core principle, write once, run anywhere, makes Java unique as compiled data code can run on any system equipped with Java Virtual Machine known as JVM, regardless of underlying hardware or operating system. Now, why learn Java? Java continues to be one of the most popular and in-demand programming languages globally. It is used extensively in web application development, mobile app development, enterprise-level application, big data technologies, and cloud-based solutions. Java's robustness, portability, and community support make it an essential language for both beginners and experienced developers. Key features of Java. Platform independence. Java programs are compiled into bytecode which can be executed on any device that has a JVM. This feature makes Java extremely flexible and suitable for cross-platform development. Strong memory management and security. Java includes automatic garbage collection to manage memory efficiently, freeing unused objects automatically. Additionally, it has a robust security model including runtime checking and secure APIs to prevent threats like virus and unauthorized access. Multi-threading support. Java supports multi-threading, which allows developers to write programs that can perform multiple tasks simultaneously. This feature is essential for high-performance applications like gaming, real-time systems, and servers. Rich API and libraries. Java comes with a vast collection of standard libraries, APIs, that simplify tasks like networking, data structures, utilities, file handling, and graphical user interface development. Now, popular Java applications. Java is the backbone of many critical applications worldwide. Some of its most well-known uses include Android app development, online banking system, web applications like LinkedIn and Twitter backend components, enterprise software, scientific computing, and even large-scale data analysis platforms. Java's ongoing evolution with continuous updates and new features ensures it remains relevant and powerful for modern development needs. Whether you are developing simple web applications or complex enterprise software, Java's stability, scalability, and robust community support makes it a trusted choice for millions of developers. So, in summary, learning Java not only equips you with a versatile programming skill but also opens door to a vast range of career opportunities in various industries. So now that we have learned this, let us move on to the next slide. Here in this particular slide, we will be discussing about setting up the Java development environment. First of all, we need to go through the slide carefully. To start Java development, install the JDK Java Development Kit and set the path environment variable. You can write code in any text editor or use IDEs like Eclipse or IntelliJ. Compile and run using javac and Java commands. Save as helloworld.java. Class hello world within curly braces public static void main string array arguments within curly braces system.out.println hello world curly braces close. Now /save as helloworld.java. This is a command telling you to save your file with the name helloworld.java. In Java, the file name must match the public class name. Class Hello World. Class Hello World defines a class named Hello World. In Java, everything runs inside a class because Java is an object-oriented language. The class is the blueprint from which objects are created. Public static void main string array arguments. This is the main method. Let's break it down. Public. It is an access modifier, meaning this method can be accessed from anywhere. Static. It means the method belongs to the class itself and not to objects created from the class. Void. The method returns nothing. Main. This is the entry point of every Java program. The Java Virtual Machine JVM looks for this method to start execution. String array arguments. This is an array of strings that holds any command line arguments passed when running the program. System.out.println hello world. System, a built-in Java class that provides access to system resources. Out, a static object of system that represents the standard output stream. Println, a method that prints the text inside the parenthesis to the console and move the cursor to the next line. Hello world, a string literal that gets printed. Curly braces close, curly braces close. These are closing braces for the main method and the hello world class. So this demonstrates that setting up basic Java development environment and writing a simple program is straightforward and beginner friendly. To begin Java development, you need to install the JDK Java Development Kit, which provides all necessary tools like the compiler and runtime. After installation, it's essential to set up the path environment variable so your system can recognize Java commands from any directory. You can write Java code using a basic text editor like Notepad, or for a better experience, use integrated development environments such as Eclipse, IntelliJ IDEA or NetBeans. These IDEs offer features like syntax highlighting, error detection and easy debugging. The sample code provided is the classic Hello World program, which is traditionally the first program developers write when learning a new language. This program introduces code concepts of Java, the class structure, which is the foundation of Java object-oriented design, the main method, which serves as the entry point where program execution begins, the system.out.println method, which outputs text to the console. Here's a quick overview of how it works. You write your code and save it with the same name as your public class. Example, helloworld.java. Next, open your terminal or command prompt, navigate to the directory where your file is saved and run the following commands. javac helloworld.com. To compile the code, this generates a helloworld.class file Java Hello World to run the compiled bytecode using the JVM. When executed, you will see the output Hello World printed on your screen. This simple example introduces you to the essential of Java's architecture, writing code, compiling it and running it through the JVM. Mastering these basic sets a strong foundation for building more complex applications. Java's portability, reliability and extensive library support make it one of the best choices for beginners and professionals alike, covering everything from small apps to large-scale enterprise systems. So now that we have learned this, let us move on to the next slide. So here in this particular slide, we will be discussing about Java basics, syntax, variables and data types. So first of all, we need to go through the slide carefully. Understanding Java syntax, case sensitive and semicolon usage, variables and data types, primitive data types, int, double, char, boolean, non-primitive types, string, arrays, classes, demo, declaring and using variables, int age equals to 25, double price equals to 99.99, car grade equals to A, boolean is Java fun equals to true. Typecasting, double my double equals to 9.78, int my int equals to int my double. So this demonstrates that understanding Java's syntax and its data types is fundamental to writing error-free and efficient programs. Java has a strict and well-defined syntax that ensures clarity and consistency across code bases. One of the key points is that Java is case sensitive, meaning identifiers like age and age are considered completely different. Every Java statement must end with a semicolon, which tells the compiler that the statement is now complete. Variable and data type. Variable are containers for storing data. In Java, every variable must be declared with a specific data type that determines the kind of data it can hold. Java has two broad categories of data types. Primitive data types. These are the basic building blocks of data manipulation. Int for whole numbers. Example, int age equals to 25. Double for decimal numbers. Example, double price equals to 99.99. Car for single characters. Example, car grade equals to A. Boolean for true or false values. Example, Boolean is Java fun equals to true. Non-primitive data types. These are more complex and include string, a sequence of characters. Example, hello world, arrays, classes and objects. Example, int age equals to 25, double price equals to 99.99. In the above code, age holds an integer value. Price holds a decimal number. Typecasting. Java is a strongly typed language, meaning you cannot directly assign one type to another if they are incompatible. However, typecasting allows you to convert data from one type to another. There are two types. Automatic casting, converting a smaller type to a larger type. Example, int to double. Narrowing or manual casting, converting a larger type to a smaller type, which requires explicit casting. Double my double equals to 9.78. Int my int equals to int my double. In this case, the decimal part 0.78 will be truncated and my int will store 9. By mastering variables, data types and typecasting, you build a solid understanding of Java's core principles. These basics form the foundation for creating more advanced logic, handling data safety and optimizing memory usage in your programs. So now that we have learned this, let us move on to the next slide. So here in this particular slide, we will be discussing about control flow, conditions and loops. First of all, we need to go through the slide carefully. Conditional statements: if, else, switch. Int num equals to 10 if num is greater than 0, system.out.println positive number, else system.out.println negative number. Int num equals to 10. This line declares a variable named num of type int and assigns it the value 10. This means num now holds the value 10 in memory. If num is greater than 0, this is an if statement. If checks whether the condition inside the parenthesis is true. Here it checks if num is greater than 0. Since num is 10, the condition is true. If is a keyword that runs a block of code only if the condition is true. System.out.println positive number. This is the block of code that executes if the if condition is true. It prints positive number to the console because the number 10 is indeed positive. Else. The else block will learn only if the if condition is false. Since num is greater than 0 is true here, this block is skipped. System.out.println negative number. If the if condition were false, example if num was -5, this statement would execute and print negative. So this demonstrates that conditional statements in Java are essential for controlling program flow based on specific conditions. Java provides several types of conditional statements including if, else and switch, which will allow a program to make decisions and execute different code blocks depending on the situation. In the provided code example, we first declare an integer variable num and assign it the value 10. Then if statement checks whether the number is greater than 0. If the condition is true, Java executes the block inside the if block and prints positive number. If the condition is false, Java program moves to the else block and prints negative number instead. Conditional statements are the backbone of decision making in Java programs. The if statement is used when you need to execute a block of code only if a specific condition is true. The else block provides an alternative actions when the if condition is not met. Java also offers else if for multiple conditions and a switch statement for cases where a single variable is tested against different values. For example, a switch can be handy if you want to perform different actions based on a day's number or numerical option chosen by the user. For example, int day equals to 3, switch day within braces case 1 system.out.println Monday break, case 2 system.out.println Tuesday break, case 3 system.out.println Wednesday break, default system.out.println other day. In this example, because day is 3, the output will be Wednesday. Conditional statements make your programs dynamic and interactive. Without them, programs would only execute in a straight line without any logic. Learning how to use if, else and switch effectively allows you to handle various real-world scenarios like input validation, error handling and more complex workflows. So now that we have learned this, let us move on to the next slide. So here in this particular slide, we will continue discussing about the control flow, conditional and loops. So first of all, we need to go through the slide carefully. Loops: for, while, do while. For loop: for int I equals to 1, I less than equals to 5, I plus plus. System.out.println iteration plus I. While loop: int I equals to 1, while I is less than equals to 5, system.out.println iteration plus I plus plus. For I equals to 1, I less than equals to 5, I plus plus. This is a for loop used when you know exactly how many times you want to repeat a block of code. Int I equals to 1, initialize the loop counter I with 1. I less than equals to 5, the condition the loop keeps running as long as I is less than or equal to 5. I plus plus. This is the increment that increases value I by 1 after every iteration. System.out.println iteration plus I. This prints iteration followed by the current value of I during each loop cycle. It shows which iteration the loop is on. While loop: int I equals to 1. Here we initialize I to 1 before starting the while loop. While I less than equals to 5. This is a while loop which keeps running as long as the condition is true. Here the loop continues while I is less than or equal to 5. System.out.println iteration plus I. Just like before, it prints iteration plus the current value of I plus plus. This increments I by 1 after each loop, moving it closer to the stopping condition, I greater than 5. So this demonstrates that loops in Java are essential for executing a block of code multiple times without writing repetitive statements. Loops allow us to perform tasks repeatedly and efficiently. Java provides several types of loops: for, while and do while. The for loop is used when the number of iterations is known beforehand. In the given example, we use a for loop that starts with 1, checks the condition I less than equals to 5, increments I by 1 after each loop. This loop prints iteration 1, iteration 5. The syntax of the loop includes initialization, condition checking and increment in a single line, making it compact and easy to read. The while loop is useful when the number of iteration is not known. In advance, you want the loop to be continue as long as a certain condition remains true. In our example, we initialize I to 1 and use a while loop that keeps running while I less than equals to 5. Inside the loop, it prints the current iteration and increments I by 1. This produces the same output as the for loop, but it's written slightly differently. In a while loop, the initialization is done outside the loop, and the increment must also be manually included inside the loop block. Both loops are functionally similar here but serve different use cases. For example, the for loop is ideal for iterating through arrays or running a loop fixed number of times. The while loop is often used in situations where the end condition is dependent on external factors like reading data from a file or user input. Java also offers a do while loop which is similar to the while loop but guarantees that the loop body runs at least once, even if the condition is false from the beginning. Understanding loops is critical because they allow your programs to handle repetitive tasks efficiently, saving time and reducing code duplication. The form the basic of many real-world programming tasks like traversing arrays, automating repetitive process, and building iterative application. In conclusion, loops make your code dynamic, flexible, and powerful by enabling repetition with controlled logic. So now that we have learned this, let us move on to the next slide. Here in this particular slide, we will be discussing about methods and functions. First of all, we need to go through the slide carefully. Creating and calling methods. Public class main static void greet. Within curly braces system.out.println hello welcome to Java. Curly braces close, public static void main string array arguments, greet method, curly braces close, curly braces close. So, public class main. This line defines a class named main. In Java, every application must have at least one class and the main class is often where the program starts. Static void greet. This line declares a method named greet. The method has the following characteristics. Static. This keyword indicates that the method belongs to the class itself rather than an instance of the class. It can be called without creating an object of the class. Void. This indicates that the method does not return any value. Greet. The method name is greet. The empty parenthesis indicate it does not take any arguments. System.out.println hello welcome to Java. Inside the greet method, we have a statement that prints the string hello welcome to Java to the console. This is the action the greet method performs when called. Now curly braces close. This closes the greet method definition. Public static void main string array arguments. This line defines the main method, which is the entry point for any Java program. Public. This means the method can be accessed from anywhere. Static indicates that it can be called without creating an instance of the class. Void. The method does not return any value. Main string arguments. The signature of the main method where string array arguments allows the program to accept command line arguments. Greet method. So this line calls the greet method. When the program reaches this line, it executes the code inside the greet method, which prints the message to the console. Curly braces close, curly braces close. This closes the main method and the main class. So this demonstrates that methods in Java are essential for organizing code into reusable blocks and improving program structure. Methods allow developers to break down a program into smaller, manageable tasks. By using methods, you can define specific actions and then call them whenever needed, avoiding repetition and promoting code reusability. In the provided code, we create a simple Java program that defines a method called greet. The greet method prints a welcoming message to the console. It's a static method, meaning it belongs to the class and can be called directly without needing an instance of the class. This is useful for utility functions that don't depend on object state. The main method is the starting point of any Java program. When you run a Java application, the JVM looks for the main method to begin execution. In this program, inside the main method, we call the greet method. When greet is invoked, the program executes the code inside the greet method, which prints the message hello welcome to Java to the console. Methods in Java are highly useful for code organization and clarity. They allow you to encapsulate specific functionality and reuse it throughout your program. For example, if you needed to display a greeting message in several places, you could call the greet method instead of repeating the system.out.println statement each time. Java methods can also accept parameters, allowing them to work with different inputs. For example, you could modify the greet method to accept a name and print a personalized message. This increases the flexibility and reusability of methods, making them adaptable to various situations. So here's an example of method that takes a parameter. Let's say static void greet within parenthesis string name. Now curly braces on system.out.println hello, comma plus name plus welcome to Java. So now you can call this method with different names. Greet within parenthesis Alice, greet within parenthesis Bob. In conclusion, mastering method creation and usage is crucial for writing efficient, maintainable Java code. Methods provide a way to encapsulate functionality, promote reusability, and improve program organization. So now that we have learned this, let us move on to the next slide. So here in this particular slide, we will be discussing about method parameters and return values. So first of all, let's go through the slide carefully. Static int add within parenthesis int a int b within curly braces return a plus b. So static int add int a comma int b. This line defines a method named add. The method has the following characteristics. Static. This keyword means that the method belongs to the class itself, not an instance of the class. You can call it directly on the class without needing to create an object. Int. This indicates the method returns an integer value. Add int a comma int b. The method takes two integer parameters a and b. These parameters are placeholders for the values passed to the method when it is called. Return a plus b. This line performs the addition of the two parameters a and b and returns the result to the caller. The return statement sends back the sum of a and b as the output of the method. Now curly braces close. This closes the add method. So this demonstrates that methods in Java allow you to define reusable blocks of code that can perform specific tasks and return values. In this case, add method, we define functionality to add two integers and return the result. Methods like these enhance the flexibility and maintainability of the program by avoiding redundant code. The provided code defines a simple method add that takes two integer parameters a and b and returns their sum. The static keyword allows this method to be called on the class itself without needing to create an instance of the class. This is particularly useful for utility functions like arithmetic operation. They don't require object-specific behavior. The method signature static int add int a comma int b tells the program several things. Static. The method is class level, meaning it belongs to the class itself and can be called without an object of the class. Int. The method returns an integer. This is the data type that will be sent back when the method completes. Add int a comma int b. The method name is add and it takes two integers a and b as input. Inside the method, the statement return a plus b adds the values of a and b and returns the result. The return type is int, meaning the method will return an integer which is the sum of the two arguments. When the method is called, the result of the addition will be returned to the caller. Methods like add are highly reusable as they can call from multiple places in the program with different arguments, and they will return the sum of any two integers. For example, you could call the method with int result equal to add within parenthesis 3, 5. This would store the value 8 in the result variable. By using methods in this way, you can organize code logically and reduce repetition. Instead of writing the same code to add numbers in multiple places, you can call the add method whenever needed. Moreover, Java allows methods to return different types of data, not just integers. This can include other primitive types, objects, or even complex structures. Java's flexibility with method signatures, including multiple parameters and different return types, is a key feature for building clean, efficient, and modular programs. In conclusion, methods play a critical role in Java's programming by enabling code reuse, organizing functionality, and providing clear structure for performing tasks. The add method demonstrates how simple arithmetic tasks can be encapsulated and reused across our program, promoting efficient, maintainable, and a modular code. So now that we have learned this, let us move on to the next slide. So here in this particular slide, we will be discussing about object-oriented programming concepts. First of all, we need to go through the slide carefully. Classes and objects. Class car within curly braces string brand equals to Tesla. Public class main within curly braces public static void main string array arguments within curly braces car my car equals to new car system.out.println mycar.brand curly braces close curly braces close. So class car. This line declares a class named car. In Java, a class serves as a blueprint for creating objects. It defines the properties, fields, and behaviors methods that the objects of the class will have. Here the class will contain one property. String brand equals to Tesla. Inside the car class, we defined a field or instance variable called brand. This variable is of type string and is initialized with the value Tesla. This means that any car object created will have a brand property with the value Tesla unless modified later. Curly braces close. This closes the car class definition. All the properties and methods related to the car classes are encapsulated within this curly brace. Public class main. This line defines the main class of the program named main. In Java, the program execution starts from the main method. The class main is where the program will begin running. Public static void main string array arguments. This line defines the main method, which is the entry point of any Java application. It's where the program begins its execution. Public. The method is accessible from anywhere. Static. The method belongs to the class, not an object, so it can be called without creating an instance of the class. Void. The method doesn't return any value. Main string array arguments. The method signature where arguments allows the program to accept command line arguments. Car. My car equals to new car. This line creates an object of the car class. The new car method part instantiates a new car object, and this object is assigned to the variable my car. The my car variable is now a reference to the newly created car object. System.out.println mycar.brand. This line accesses the brand property of the mycar object and prints to the console. Since the brand is initialized to Tesla, when the car object is called, it will print Tesla. Now curly braces close, curly braces close. This line closes the main method and the main class. So this demonstrates that Java is an object-oriented language where classes serve as blueprints to create objects and objects hold specific data and behaviors. The concept of classes and objects from the foundation of object-oriented programming, allowing developers to organize and manage complex systems by grouping related properties and behaviors together. So in this code, we define a class car which contains a field named brand. This field holds a value Tesla, representing the brand of a car. When the car class is used, every object created from this class will have a brand property with the same value unless explicitly modified. The main class contains the main method, which is the entry point of any Java program. Inside the main method, we instantiate a new object of the car using the new car expression. This creates an instance of the car class and we assign it to the variable myCar. The variable myCar now holds a reference to the specific object in memory. When we print mycar.brand, we are accessing the brand property of the car object referred by mycar. Since the field brand is initialized to Tesla, the program prints Tesla to the console. This example highlights the key concept of object-oriented programming in Java. Classes, blueprints for creating objects, defining their properties and behaviors. Objects, instances of a class that stores specific data. Each object has its own set of fields and methods. Encapsulation. By grouping related properties like brand inside the car class, we can ensure that data is managed and accessed in a structured way. In real-world application, objects can represent real entities like car, books, employees, or even abstract concepts. By organizing the program into classes and objects, we can build modular, scalable, and maintainable code. Moreover, Java allows the creation of methods inside classes to perform actions, making objects not just data holders but entities with behaviors. So this program serves as a simple introduction to the concept of classes and objects in Java. Understanding how to create objects from classes is fundamental to mastering Java and object-oriented programming. So now that we have learned this, let us move on to the next slide. So here in this particular slide, we will continue discussing about the object-oriented programming concepts. First of all, let's go through the slide carefully. Encapsulation. Encapsulation is a principle of OOP where data, variables, and methods are bundled together within a class. It protects data by making fields private and accessing them through public getters and setters, ensuring controlled access. Public class person, within parenthesis private string name, public string get name, return name, public void set name, string name, this dot name equals to name. Now curly braces close. So now class person. This line declares a class named person. The class serves as a blueprint for creating person objects. It contains data, fields, and methods, function that define the behavior of person objects. Private string name. This line defines a private field called name of type string. The private access modifier ensures that the field can only be accessed directly within the person class itself. This is an example of data encapsulation where the data is hidden from outside access to prevent unauthorized modification. Public string get name, return name. This is a getter method. It is public method that returns the value of the name field. Since the name field is private and cannot be accessed directly from outside the class, the getter method provides controlled access to retrieve the value of name. Public void set name string name. This dot name equals to name. This is a setter method. It is a public method that allows setting the value of the name field. This keyword refers to the current object's name field, distinguishing it from the name parameter passed to the method. This method allows the value of name to be modified in a controlled manner. Curly braces close. This closes the person class definition, indicating the end of the class and its methods. So this demonstrates that encapsulation is one of the most fundamental principles of object-oriented programming, which involves bundling data and methods into a single unit while controlling access to the data through specific mechanisms. Encapsulation protects the integrity of the data by restricting direct access and providing controlled access via public methods. This ensures that the internal representation of the object is hidden from the outside world, offering a higher level of security and flexibility. In the given code, the person class illustrates encapsulation through its private field name. By making name private, we prevent external code from directly accessing and modifying this field. This is crucial for maintaining control over how data is used and modified within an object. Without encapsulation, any external code could change the name field directly, which may lead to inconsistent or invalid data. To provide controlled access to the name field, two public methods are used, the getter method and the setter method. The getter method allows other code to access the value of the name field in a read-only manner. By using this method, external class can retrieve the value of name without directly accessing the field. On the other hand, the setter method allows controlled modification of the name field. The setter method validation or processes the value before assigning it to the private field, ensuring that the object state remains valid and consistent. In this case, there is no validation, but more complex scenarios may require input checks or restrictions, which can easily be implemented in the setter method. Encapsulation has several key benefits. Number 1. Data protection. By keeping fields private and only allowing controlled access through getters and setters, encapsulation ensures that data cannot be altered directly by external entities, protecting the object's integrity. Code flexibility. If the internal representation of the class needs to change, encapsulation allows this to happen without affecting external code. The public interface, the getter and setter methods can remain unchanged even if the internal implementation changes. Easier maintenance. Encapsulation provides a clear separation between an object's internal details and external uses. This improves code readability and maintainability. In conclusion, encapsulation is a crucial concept in OOP that ensures data integrity and code flexibility. By bundling data and methods together and controlling access through public interfaces, encapsulation improves the robustness and maintainability of software systems. The person class is a simple yet effective example of how encapsulation works in practice. So now that we have learned this, let us move on to the next slide. So here in this particular slide, we will be discussing about inheritance. First of all, we need to go through the slide carefully. Inheritance allows a class to acquire properties and methods of another class, promoting code reuse. The extends keyword is used for inheritance. The parent class is the superclass and the child is the subclass. Class animal void sound system.out.println animal makes sound curly braces close class dogs extends animal within curly braces void bark system.out.println dog barks. So class animal. This line defines a class named animal. It acts as the parent class, also called the superclass in this example. The animal class contains a method that will be inherited by other classes. Void sound. System.out.println animal makes sound. This defines a method named sound inside the animal class. The method is of void type, meaning it doesn't return anything. When called, it prints the message animal makes sound to the console. This is a general behavior that all animals share. Now curly braces close, this closes the animal class. Class dog extends animal. This line declares a new class called dog, which inherits from the animal class using the extends keyword. This means the dog class is a child class, also called the subclass, and automatically gets access to all non-private methods and field of the animal class. This enables code reuse because dog can use the sound method of animal without rewriting it. Void bark. System.out.println dog barks. This defines a new method named bark inside the dog class. This method is unique to dog and is not inherited from animal. When called, it prints dog barks to the console. showing additional behavior specific to dogs. Now curly braces close, this closes the dog class. So this demonstrates that inheritance is a key concept in object-oriented programming that allows one class to inherit fields and methods from another class, enabling code reuse, extensibility, and logical hierarchy. Inheritance simplifies code by allowing subclasses to reuse the methods of their parent classes while also adding their own unique features. In the given code, the animal class is a superclass that contains a single method, sound, which prints a generic message animal makes sound. This method represents a common characteristics of all animals. The dog class is a subclass of animal, meaning it inherits the behavior defined in animal. This relationship is established using the extends keyword. By inheriting from animal, the dog class does not need to redefine the sound method. It can directly use it, promoting code reuse and reducing redundancy. In addition to the inherited method, the dog class defines its own method, bark, which prints dog barks. This method is specific to the dog class, illustrating that while a subclass can reuse the parent class functionality, it can also introduce new behavior. Inheritance provides several benefits. Code reusability. The dog class can use existing methods from animal without rewriting them, making the code base smaller and easier to maintain. Extensibility. You can add more subclasses like cat, bird, etc., which can inherit from animal and implement their own unique method while still sharing common behaviors. Polymorphism support. Through inheritance, Java supports polymorphism, allowing one interface to be used for different data types. This structure also maintains a logical hierarchy. Dog is a type of animal. This mirrors real world relationships, making code more intuitive and easier to understand. In conclusion, the example showcases single inheritance in Java, where one class extends another. The dog class inherits the generic behavior from animal while defining its own specific behavior. This is the essence of inheritance, reusing existing code and extending functionality to build more specified and complex systems efficiently. So now that we have learned this, let us move on to the next slide. So here in this particular slide, we will be discussing about polymorphism. So first of all, we have to go through the slide carefully. Polymorphism means one action behaves differently based on the object. It allows methods to perform different tasks using the same name, method overriding or method overloading. It helps in flexibility and reusability. Class animal void sound system.out.println animal sound. Class dog extends animal void sound system.out.println dog barks. Now, class animal. This line declares a class named animal. It serves as the parent class in this example. Void sound system.out.println animal sound. Class dog extend animal void sound system.out.println dog barks. Now curly braces close. So now class animal. This line declares a class named animal. It serves as the parent class in this example. Void sound system.out.println animal sound. Inside the animal class there is a method named sound. This is a general method for all animals, and when called, it prints animal sound to the console. The method is of type void, meaning it does not return anything. Curly braces close. This closes the definition of the animal class. Class dog extends animal. This declares a new class called dog, which inherits from the animal class using the extends keyword. The dog class is a child class or subclass of animal. Void sound system.out.println dog barks. Here the dog class overrides the sound method of its parent animal class. Even though the method name is the same, the behavior is different. This time it prints dog barks. When called, this is an example of runtime polymorphism or method overriding. Now curly braces close, this closes the dog class. So this demonstrates that polymorphism is a powerful feature in Java's object-oriented programming model, allowing a single method to behave differently based on the object that invokes it. In simple terms, polymorphism means poly, many forms. It provides flexibility and makes code easier to maintain and extend. In the provided code, there are two classes, animal and dog. Both classes have a method named sound. The animal class sound method prints animal sound, while the dog class's sound method prints dog barks. Even though the method name is the same, the output changes depending on the actual object that calls it. This is an example of runtime polymorphism or dynamic method dispatch. At runtime, Java decides which version of the method to call based on the object type. For example, if you create an object of type animal, it will call the animal sound method. If you create an object of type dog, even if it's referenced as the animal, it will call the overridden sound method in the dog class. Polymorphism is essential for code flexibility. You can write more generic and reusable code. Extensibility. New subclass can override method without affecting existing code. Improved maintenance. Changes in subclass do not require changes in the parent class. In conclusion, this example shows how polymorphism allows the same method name to perform different action, making Java programs more dynamic and easier to extend. So now that we have learned this, let us move on to the next slide. So here in this particular slide, we will be discussing about constructors. So first of all, we have to go through the code line by line properly. Class, person, string, name, person, string, new name, within curly braces, name equals to new name, curly braces close, curly braces close. So class, person. This line defines a class named person. A class is a blueprint for creating objects in Java. String, name. Inside the person class, a field instance variable named name of type string is declared. This variable will store the name of a person. Person, string, new name. This line defines a constructor for the person class. A constructor is a special method that is called automatically when an object is created. The constructor has the same name as the class person and it takes a parameter new name of type string. Name equals to new name. This line assigns the value of the parameter new name to the class instance variable name. This sets the object's name when it is created. Curly braces close. This closes the constructor definition. Curly braces close. This closes the person class. So this demonstrates that constructors are essential in Java for initializing objects when they are created. A constructor is a special block of code that automatically executes when an object of the class is instantiated. Unlike regular methods, constructors do not have a return type and their name must exactly match the class name. In this example, we have a class person with a single variable name. To initialize this variable at the time of object creation, the class includes a constructor that accepts a parameter new name. When an object of person is created, the constructor takes the provided name and assigns it to the name field of the object. For example, person P equals to new person John. Here new person John will call the constructor passing John as the argument. The constructor sets the name of the person object to John. Constructors are useful for initializing objects with default or custom values. Overloading, you can have multiple constructors with different parameter list. Constructor overloading. Code clarity, they make sure objects start in a valid state. If you don't define any constructor, Java automatically provides a default constructor with no parameters. However, once you define your own constructor, the default one is not available unless you create it explicitly. In summary, this example shows how constructors ensure that each object of a class starts with the required data, improving the robustness and flexibility of Java programs. So now that we have learned this, let us move on to the next slide. So here in this particular slide, we will be discussing about interfaces and abstract classes. First of all, we need to go through the slide carefully. An instance defines a contract with abstract methods, no body. While an abstract class can have both abstract and concrete methods, interface support multiple inheritance. Abstract classes provide base functionality. Interface animal. Within curly braces, void sound method. Abstract class bird. Within curly braces, abstract void fly method, void eat method. Within curly braces, system.out.println bird eats. Curly braces close, curly braces close. Interface animal. This line declares an interface named animal. An interface in Java is a blueprint that can contain abstract methods without body. It sets a contract for classes to follow. Void sound. Inside the interface, there is a method declaration, sound with no body. Any class that implements this interface must provide an implementation for this method. Curly braces close. This closes the interface definition. Abstract class bird. This line declares an abstract class named bird. An abstract class can have both abstract and concrete methods and cannot be instantiated directly. Abstract void fly. This is an abstract method fly, meaning it does not have a body and must be implemented by subclass of bird. Void eat. System.out.println bird eats. This is a concrete method named eat that prints bird eats when called. Abstract classes can include such concrete methods to provide shared behavior. Curly braces close. This closes the abstract class. So this demonstrates that interface and abstract classes are key tools in Java for creating flexible and organized code structure. An interface defines a set of methods that a class must implement, effectively setting a contract. In this example, the animal interface declares a method sound, which means any class implementing animal must define exactly how sound behaves. Interfaces are powerful because they allow multiple inheritance of type. A class can implement multiple interfaces, which helps Java maintain flexibility despite not supporting multiple class inheritance. In contrast, the bird abstract class shows a different concept. Abstract classes can have both abstract method like fly and concrete method like eat. The abstract method fly requires subclass to provide their own flying behavior, while eat already provides a shared implementation. Now, class sparrow extends bird. Void fly method within curly braces system.out.println sparrow flies. Here, sparrow must implement fly method by can use the existing eat method as it is. In summary, interfaces are used when you need to define a contract for unrelated classes to follow. Abstract classes are used when you want to provide shared code and force certain behaviors in subclasses. Together, they enable polymorphism, code reusability, and better software design, making your Java program scalable and well structured. So now that we have learned this, let us move on to the next slide. So here in this particular slide, we will be discussing about exception handling and file handling. First of all, we need to go through the slide carefully. Try catch blocks. Try within curly braces int result equals to 10 divided by 0. Catch arithmetic expression e within curly braces system.out.println cannot divide by 0. So try. The try block is used to wrap code that might throw an exception. It tells Java, try to run the code inside this block, but if an error happens, handle it. Int result 10 by 0. Inside the try block, we are trying to divide 10 by 0. In Java, dividing by 0 causes an arithmetic exception because it is not allowed mathematically. Catch arithmetic exception E. The catch block catches the exception that was thrown in the try block. Here it is specifically catches arithmetic exception, which is the type of exception that occurs during division by 0. Arithmetic exception E. This declares a variable E of type arithmetic exception which holds the details of the error. System.out.println cannot divide by 0. If the exception is caught, this line prints a user-friendly message to let us know what went wrong, instead of stopping the program with a crash. Now curly braces close, this closes the catch block. So this demonstrates that the catch block in Java is essential for handling errors gracefully, allowing a program to continue running even if something goes wrong. In the provided example, the try block attempts to divide 10 by 0, which is mathematically undefined. In Java, this triggers an arithmetic exception, a built-in error type that handles arithmetic problems like division by 0. Without exception handling, this operation would crash the entire program. However, by placing the risky code inside the try block, Java can try the operation and catch any problems that arise. When the error occurs, the catch block immediately takes over, preventing the program from crashing. Here, the message cannot divide by 0 is printed, which provides clear feedback to the user. The syntax use try to hold the risky code, catch to capture and handle the error. You can also catch different types of exception by writing multiple catch blocks to handle various errors differently, making the program robust. For example, in file reading or network communication, errors are common. Using try-catch blocks ensure your application does not fail unexpectedly and can handle issues smartly, like prompting the user or retrying an operation. In summary, exception handling with try-catch ensures better user experience, reliability, and stability of your Java application. So now that we have learned this, let us move on to the next slide. So here in this particular slide, we will be discussing about reading and writing files in Java. First of all, we need to read the slide carefully. Import java.io.filewriter, import java.io.io exception, public class main, public static void main, string array arguments. Now try block, within try block curly braces on, file writer equals to new file writer test.text, writer.write hello Java file handling, writer.close catch IO exception E system.out.println and error occurred, curly braces close, curly braces close, curly braces close. Import java.io.filewriter, import java.io.io exception. This imports two classes, file writer allowing writing text to a file, IO exception handles errors that may happen during file operation like writing issues. Public class main declares the main class where our code is written. Public static void main string array arguments, the main method which is the starting point of any Java program. Try starts a try block where we place code that might cause an exception, in this case file writing. File writer equals to new file writer text.txt. This creates a file writer object named writer. It opens or creates, if not present, a file called test.text in the current directory ready to be written to. Writer.write hello Java file handling. This writes the string hello Java file handling into test.text. Writer.close. This important to close the file after writing to ensure all data is saved and the file is properly closed. Catch IO exception E. If any error happens during file writing, like permission issues, the IO exception is caught here. E is the variable that holds details about the error. System.out.println an error occurred. Prints an error message if the file operation fails. Curly braces close, curly braces close. Closes the method and the class. So this demonstrates that Java provides simple yet powerful file handling capabilities through classes like FileWriter, allowing developers to create and write files efficiently. In the provided example, we see a complete demonstration of writing data to a text file safely and reliably. First, we import the FileWriter and IO exception class from the java.io package, which provide the tools for file operation and error handling. The main method then starts the process. Inside a try block used to catch potential errors, we create a FileWriter object called writer, targeting a file named test.txt. If the file doesn't exist, Java automatically creates it. Using the writer.write method, we add the next hello Java file handling to the file. Once writing is complete, we close the file using writer.close method, which is a crucial step. Closing the file ensures that all data is properly written and the system resources are released. If any issue arises during these operations, such as lack of file permissions or disk issues, an IO exception is triggered. The catch block captures this error and displays a friendly message: an error occurred. This makes the program robust and user-friendly, preventing it from crashing unexpectedly. This code demonstrates how Java manages file input-output with built-in error handling, ensuring safe and reliable file creation and writing. Proper use of try-catch blocks is essential in file handling because file operations are sensitive to environmental factors. This technique is used in many real-world applications like logging, saving user data, and configuration files. So now that we have learned this, let us move on to the next slide. In this particular slide, we will be discussing about Java Collections Framework. First of all, we need to go through the slide carefully. Introduction to Collections API. ArrayList example. Import java.util.arraylist public class main public static void main string array arguments curly braces on array list within diamond braces string cars equals to new array list. Cars.add Toyota, cars.add Honda, system.out.println cars. Curly braces close, curly braces close. So now import java.util.arraylist. This line imports the ArrayList class from the java.util package. Java's standard library has many utility classes. An ArrayList is a resizable array implementation of the list interface. Public class main declares a public class named main. In Java, the program must have at least one class and the file name should match the class name. Public static void main string array arguments. This is the main method, the entry point of every Java application. The program starts executing from here. It takes an array of strings arguments as a parameter, allowing command line arguments. ArrayList string cars equals to new ArrayList. This creates a new ArrayList named cars that stores string values. ArrayList string means this list will only hold string data. New ArrayList creates an empty list ready to store items. Cars.add Toyota adds the using add method adds the string Toyota to the cars. The add method is used to insert elements into the array list. Cars.add Honda adds the string Honda to the list. Now the cars list contains two items, Toyota and Honda. System.out.println cars. This prints the entire car's array list to the console. The default toString of an array list prints its elements in square brackets, like within square brackets Toyota, Honda. Now curly braces close, closes the main method and the class. So this demonstrates that Java's collection API provides a powerful and flexible way to store and manipulate data efficiently. In the given code, the ArrayList class is used, which is part of java.util package and implements the list interface. Unlike regular ArrayList in Java, which have a fixed size, an ArrayList can dynamically grow or shrink as elements are added or removed. This makes it much more convenient when working with collections of data where the size isn't known in advance. The program starts by importing the ArrayList class and define a main class containing the main method. Inside the main method, an ArrayList of type string is created. This ensures that only string type data can be stored, preventing accidental insertion of other types, which helps maintain type safety. The add method is then used to insert two car names, Toyota and Honda. Each time add method is called, the new element is added to the end of the list. After adding the elements, the program prints the entire array list using system.out.println. Java's ArrayList overrides the toString method, so the output displays all elements neatly in square brackets, separated by commas. The collection API simplifies many common tasks such as searching, sorting, and iterating over data. It offers other types of collections too, like linked list, hashed, and hashmap, each with its unique behavior. An ArrayList is particularly useful when you need fast random access to the elements. Overall, this example shows the basics of how to use an ArrayList, highlighting its flexibility and ease of use compared to traditional arrays. It also emphasizes how Java's type-safe collections help prevent runtime errors and make code more robust. So now that we have learned this, let us move on to the next slide. So here in this particular slide, we will continue discussing about the Java collection framework. First of all, we need to go through the slide carefully. Hashmap example. Import java.util.hashmap public class main within curly braces public static void main string array arguments hashmap string comma integer ages equals to new hashmap ages dot put alice comma 25 ages dot put bob comma 30 system dot out dot println ages dot get alice curly braces close. So now import java.util.hashmap. This line imports the hashmap class from the java.util package. Hashmap is part of the collections framework and allows us to store key value pairs. Public class main. This declares a public class named main. Every Java application needs at least one class. Public static void main string array arguments. This is the main method, which is the entry point of any Java application. Hashmap within diamond braces string comma integer ages equals to new hashmap. This creates a new hashmap named ages. The key type is string. Names like Alice, Bob, the value type is integer. Ages like 25 and 30. New hashmap. Initialize an empty map where we can store these pairs. Ages.put Alice, 25 adds a key value pair to the hash map. Here Alice is the key and 25 is the value. Ages.put Bob, 30 adds another pair, Bob as the key and 30 as the value. Now the map has two entities. System.out.println ages.get of Alice retrieves the value associated with the key Alice using the get method and prints it. The output will be 25. Now curly braces closes closes the main method and the class. Now, so this demonstrates that Java's hash map is a highly useful data structure for storing and retrieving data in the form of key value pairs efficiently. The code above uses the hash map class from the java.util package to map names to ages. Unlike arrays or lists, which use numerical indexes, a hash map allows you to assign a unique key to each value, making it perfect for scenarios where fast lookups are needed based on meaningful identifiers. The program begins by importing hash map and defining a main class with the usual main method. Inside the method, a hash map named ages is created. The string, integer part specifies that the map will link string keys like names to integer values like ages. This type safety ensures only valid data type are inserted. The put method is then used to insert two key value pairs. Alice is mapped to 25 and Bob is mapped to 30. These pairs are stored in an internal structure that allows extremely fast retrieval. To demonstrate retrieval, the code calls ages.getAlice, which fetches the value 25 associated with the key Alice and prints it. If a non-existing key is queried, null is returned. The hash map is a part of Java's collections framework and provides constant time performance for basic operations like put, get under normal conditions. It's widely used for cases such as caching, mapping, configuration, and handling relationships between data. In summary, this code illustrates how HashMap provides a simple yet powerful way to organize and access data based on keys rather than indexes, boosting both flexibility and speed in Java programs. So now that we have learned this, let us move on to the next slide. Here in this particular slide, we will be discussing about final project and next steps. First of all, we need to go through the slide carefully. Mini project. Build a simple Java calculator using user input. So this demonstrates that Java can be used to build interactive console-based applications like a simple calculator that takes user input. In this mini project, the calculator allows users to perform basic arithmetic operations such as addition, subtraction, multiplication, and division by entering two numbers and selecting an operation. The project uses Java Scanner class to handle user input from the console. The program begins by prompting the user to enter two numbers. After that, it displays a menu asking the user to choose an operation, example plus, minus, multiplication, divide. A switch statement is then used to determine which calculation to perform based on the user's choice. Each case in the switch handles a different operation, performing the calculation and printing the result. For example, if the user selects plus, the program adds the two number and displays the result. If the user tries to divide by 0, an error message is shown to handle the exception safely. This mini project is an excellent way to practice key Java concepts such as data types, user input, conditional statements, and basic exception handling. It also reinforces how Java can be used to build real-world tools with simple logic and user interaction. So now that we have learned this, let us move on to the next slide. So here in this particular slide, we will be discussing about step 1, set up the Java project. So first of all, we need to go through the slide carefully. Create a new Java project or simply create a new file named calculator.java. So this demonstrates that setting up a Java project is the first essential step to building any application. To begin, you can create a new Java project using an integrated development environment IDE like Eclipse, IntelliJ IDEA or NetBeans, which helps organize files and manage the build process easily. Alternatively, if you are working in a simpler environment, you can manually create a new file named calculator.java using any text editor such as Notepad or VS Code. The calculator.java file will serve as the main class for your project. In Java, every application must have at least one class with a main method, which acts as the entry point of the program. By creating and saving the file properly, you set the foundation to write, compile, and run your Java code seamlessly. This step also involves ensuring your Java Development Kit JDK is installed and the environment variables like path are set up correctly, so you can compile your code using javac and run it with the Java command. Completing this setup allows you to focus on writing the logic of your calculator without worrying about configuration issues later. So now that we have learned this, let us move on to the next slide. So here in this particular slide, we will be discussing about step 2, code for the calculator. So first of all, we need to go through the slide carefully. Import java.util.scanner, public class calculator, curly braces on, public static void main string array arguments, curly braces on. Create a scanner object for user input. Scanner equals to new scanner system.in system.out.println. Welcome to the Java calculator. System.out.println select an operation. System.out.println within parenthesis 1 add system.out.println 2 subtract system.out.println 3 multiply system.out.println 4 divide. Now taking user input for the operation int choice equals to scanner.nextInt. Taking user input for the numbers system.out.print enter first number double num1 equals to scanner.nextDouble. System.out.println enter second number double num2 equals to scanner.nextDouble. Import java.util.scanner. This line imports the scanner class from the Java's utility package, which allows us to take user input. Public class calculator. This defines the main class named calculator. Public static void main string array arguments. The main method is the entry point of the Java program where execution begins. Scanner equals to new scanner system.in. Here a scanner object named scanner is created to read user input from the console. System.out.println welcome to the Java calculator displays a welcome message to the user. System.out.println select an operation. Ask the user to choose a mathematical operation. Now system.out.println 1 add. List the 4 calculator operation add, subtract, multiply and divide. Int choice equals to scanner.nextInt. Reads the user operation choice as an integer. Example 1 for add. System.out.println enter the first number. Prompts the user to input the first number. Double num1 equals to scanner.nextDouble. Reads the first number as a double, which allows decimals. System.out.print enter second number. Prompts the user for the second number. Double num2 equals to scanner.nextDouble. Reads the second number as a double. So this demonstrates that Java allows us to build interactive console application efficiently using simple tools like the scanner class for input and system.out.println for output. The code begins by importing java.util.scanner, which is essential for accepting user input. The calculator class wraps everything and the main method serves as the program's entry point. We create a scanner object linked to system.in, the console input stream, enabling the user to type data directly into the program. The code then prints a friendly welcome message and lists 4 basic arithmetic operations: addition, subtraction, multiplication and division. These instructions guide the user clearly through the next steps. The program waits for the user to enter their operation choice captured as an integer using scanner.nextInt. Next, it prompts the user to enter 2 numbers, which are read as double values, allowing the calculator to handle both integers and decimals smoothly. The foundation ensures user interaction is straightforward, making it easy for beginners to understand how input is processed. Once the inputs are collected, the programs can execute the chosen arithmetic operation based on the user's selection. Through the operation logic would follow in the next steps. Overall, this simple calculator shows how Java blends user input, control flow, and basic arithmetic to create useful real-world applications. It emphasizes structured programming, input validation if extended, and a modular way to handle user choices, preparing the ground for more advanced projects. So now that we have learned this, let us move on to the next slide. So here in this particular slide, we will continue discussing about the step 2, code for the calculator. So first of all, we need to go through the slide carefully. Double result equals to 0. Switch choice curly braces on case 1 result equals to num1 plus num2. System.out.println result colon plus result break. Case 2 result equals to num1 minus num2. System.out.println result plus result break. Case 4 if num2 is not equals to 0, result equals to num1 divided by num2. System.out.println result plus result. Else system.out.println error, division by 0 is not allowed. Break. Default system.out.println invalid choice, please select a valid operation. Curly braces close, close the scanner, scanner.close. Curly braces close, curly braces close. Double result equals to 0. This declares a variable result of type double and initialize it to 0. It will store the outcome of the selected operation. Switch choice starts a switch statement that checks the value of choice the operation selected by the user. Case 1 if the user choice 1. Add, this block executes result equals to num1 plus num2, adds num1 and num2 and stores the result in result. System.out.println result colon plus result prints the result of the addition. Break. Exit the switch block after executing case 1. Case 2 executes if the user choose to subtract result equals to num1 minus num2. Subtract num2 from number 1 and stores the result. System.out.println result colon plus result displays the subtraction result. Break exists after case 2. Case 3 executes if the user choose 3. Multiply result equals to num1 into num2. Multiplies num1 and num2. System.out.println result plus result prints the multiplication result. Break exists case 3. Case 4 executes if the user chose 4. Divide if num2 is not equals to 0. Checks if the divisor is not 0 to avoid division by 0 error. Result equals to num1 by num2. Divides num1 by num2. System.out.println result plus result displays the division result. Else executes if num2 is 0. System.out.println error, division by 0 is not allowed. Prints an error message by division by 0. Break ends case 4. Default executes if the user choice didn't match 1 to 4. System.out.println invalid choice, please select a valid operation. Alerts the user of an invalid choice. Scanner.close, close the scanner class to free up system resources. So this demonstrates that Java's control flow mechanisms like the switch statement allow a program to execute different blocks of code based on a user input, enhancing flexibility and interaction. In this calculator example, once the user selects an operation, the switch structure evaluates the choice variable and directs the program flow to the corresponding arithmetic operation. For each case, add, subtract, multiply, divide, the code performs the respective mathematical operation between num1 and num2, storing the result in a double variable named result. It then prints the result using system.out.println. The break statement after each case ensures that only the matched case executes, preventing fall through to other cases. A noteworthy part of this program is the division case. Here the code includes a crucial validation step before dividing. It checks if num2 is not 0 to avoid runtime error division by 0. If num2 is 0, the program gracefully handles it by displaying an error message instead of crashing. The default case acts as a safety net, catching any invalid inputs and informing the user that their selection was not valid. Finally, the scanner is closed using scanner.close, which is good practice to prevent resource leaks. Overall, this section of calculator project shows how Java handles multiple outcomes in a clean, organized way, ensuring the program behaves predictably and safely based on the user input. It emphasizes good programming habits such as input validation and resource management. So now that we have learned this, let us move on to the next slide. So here in this particular slide, we will be discussing about where to go next. First of all, we need to go through the slide carefully. Learn Java effects for GUI applications. Explore Spring Boot for web development. Practice coding challenges on LeetCode and HackerRank. So this demonstrates that advancing your Java skill involves not only understanding core concepts but also exploring practical frameworks and tools that enhance development capabilities. Learning Java effects allows developers to build rich GUI. GUI means graphical user interface. So, rich GUI applications with ease. Java Effects offers a modern, flexible way to create desktop applications that feature buttons, forms, charts, and multimedia components, making it ideal for projects that need interactive front ends. Exploring Spring Boot is equally crucial for those interested in web development. Spring Boot simplifies the process of creating robust, production-ready web applications and microservices. With features like embedded servers, auto-configuration, and an extensive ecosystem, Spring Boot reduces boilerplate code and accelerates the development process, making it a popular choice for building scalable, maintainable Java-based web applications. Additionally, practicing coding challenges on platforms like LeetCode, HackerRank, GFG sharpens problem-solving skills and improves algorithm thinking. Regular practice on these platforms not only prepare you for technical interviews but also strengthens your logical reasoning and coding efficiency. Altogether, diving into Java effects, Spring Boot, and coding challenges provides a balanced approach. Java effects for UI skills, Spring Boot for backend expertise, and coding platforms for algorithmic strength, laying a strong foundation for becoming a well-rounded Java developer. So now that we have learned this, let us move on to the next slide.